Hello, everyone. Welcome to this week's Office Hours on Automating Security in OpenShift Pipelines. I'm Chris Porter. I'm a Director of Solutions Architecture at Red Hat, and I have here today Neil Carpenter, who will be doing most of the presenting. He is the Senior Principal Specialist Solution Architect at Red Hat. Both of us come to Red Hat from the acquisition of a company called StackRox. You may hear us slip up a little bit and use that term. You'll see the logo here. The StackRox name is going to live on as part of our community efforts. Now, before we get started today, just a little bit of housekeeping. Everyone's on mute, so you won't be able to talk to us directly, but we would love your input. This is not a product presentation or any sort of slide deck. It is a live environment with demos and discussion, and we would love your input using the Q&A interface that you'll find in the On24 session that you're logged into there. This is not going to be an introduction to security in containers. We'll probably talk about some of the topics that are relevant there, but we will have links to resources that you can use, some of the basic stuff, and we'll be referring to that throughout this. Resources like product documentation, open source projects like Kubernetes that we'll be talking about, as well as some of the code examples that we'll use and we'll walk you through here. So since we don't have any questions yet, we'll encourage you guys to start off with that. But I'm going to hand it over to Neil for an introduction. I'll just ask the basic question. Neil, what is automating security in OpenShift pipelines? What do you want to cover today?
Yeah, so I think everybody at Red Hat likes to quote, there was an IBM study of fixing security problems in the dev phase versus QA versus acceptance, et cetera. And I'm going to look back at the numbers, make sure I remember them. But so fixing something in development test costs about 4 times as much as fixing it in code development. Fixing it in acceptance costs another 7 times that. And fixing it once you get it into operations, once you've deployed that thing, may cost up to 100 times as much as that, according to this study. And that really speaks to the DevOps process and bringing security into it. Ultimately, if we can fix something at the point we build an image that's going into the pipeline to be deployed, that's a lot easier. It means we're secure out of the box. And so what we really want to do is take those things that we're looking for when something's deployed, making sure that it's properly configured, properly built, that that the vulnerabilities in there are acceptable. I think between us, we both agree that there's no such thing as running with no vulnerabilities. But we do want to catch the vulnerabilities that are critical, that are exploitable, that are problematic. And the earlier we can address those in the cycle, the better off we are. So really, this is about taking those security policies and those security concepts, shifting them left into CI, and finding those problems and making developers aware of them. Potentially setting gates where we block builds, we block deployments based on them if they're critical enough. So I think step one, and this also goes back to DevSecOps as a concept, right? How do we bring security into DevOps? How do we build out a whole process around that? And there's a couple of things I really like there. The first one is we start treating security issues in the same way as we treat any other test for something that we're building and deploying, right? If you think about traditional DevOps, I submit a PR, and what happens is the image gets built. And then it goes through maybe unit testing to make sure that it does what it's supposed to do, go through integration testing to make sure it plays well with everything else, and eventually it goes through the pipeline and gets deployed. What we really start doing here is taking security criteria, security policy, and treating it in the same way. So not only does it pass my unit test, does it do what I expect it to do, does it play well with everything else, does it meet our defined security policy? Does it include things that ought not to include? Does it have vulnerabilities that are problematic? Whatever else. So we're building that into the process just like we're building everything else into it. And we're able to test those things, get them further left, get them into those dev phases so that we can address those issues early and ship something that is secure out of the box. And then obviously when we find issues in deployment and running code, we can search. That's the overall thought process here. And I wanted to show it with OpenShift Pipelines. I've been doing a lot of work with OpenShift Pipelines, which is based on Tekton. And it is, It's becoming one of my favorite CI pipelines, just because there's a lot you can do with it. There's some really neat capabilities. I'll show you one of those as we dive into it. But it's a really great. It's one of many great CI platforms that give you the ability to do that to take that sort of thing and do it. So what I'm doing today is I've got OpenShift Pipelines up and running. I've also got Red Hat ACS, what used to be StackRox, up and running, providing policies and providing the scanning. And we're going to look at a couple of scenarios in here just to get a feel for what's going on. And so I want to start actually in advanced cluster security in ACS. Now there are lots of different tools that I could do this sort of integration with. ACS happens to be a convenient one for you and me because we work with the product every day. But I can use other tools like kubelinter is one you'll see as when I shift back to pipelines. I've been writing an integration for kubelinter, which is an open source tool that allows you to look at Kubernetes deployments and find problems. So there are lots of things that you can do this with. ACS just happens to be the one that I'm using today. And so what I want to show you in ACS before we dive into a couple of pipelines and tasks is what in ACS directly influences this. So in ACS, we have policies. Our policies are really the heart of the product, right? They define what we want visibility into, what we want to enforce across build time, deploy time, run time. And so if I look at a typical policy here, and one we're going to see come into play in a minute, this is a policy around vulnerabilities. And if I edit this, let me just show you what we're looking for here. So we're looking for vulnerabilities where they have what's called a CVSS score, which is a measure of the criticality of the vulnerability, the common vulnerability scoring system. So that's a 10-point scale, and we're looking for anything 7 or higher, which is higher critical severity vulnerabilities. And we're looking for ones where a fix is available, but it hasn't been fixed. So the vulnerability is present in our image, but we haven't fixed it, even though we could have. So this is a pretty typical policy. This is the sort of thing from a security architect perspective that I might be looking for, right? If I have higher critical severity vulnerabilities that you could fix and you haven't, obviously we're going to be in better shape if you fix those things than if you don't. Now, there's some other policies in here that I really like. A lot of times when people look at security integration in CI, they really, really focus on vulnerabilities. And we know from long and difficult sort of the last 15 years watching things get compromised, watching companies get compromised. We know vulnerabilities are certainly a major piece of that. But misconfigurations are also a problematic piece of that, providing attackers with poorly configured code or poorly configured images, poorly configured deployments, providing them with tools once they manage to gain a foothold that allow them to do more things. There's a lot of other things that we can look for, and I'll show you. This is one I particularly like, and that is, do we have the package manager in the image? So this is something I see in a lot of sample images, is that they still have the Red Hat package manager, or the Debian package manager, or the Alpine package manager, or whatever platform they're built on, is still in the image at the point it ships. Now that makes sense. If I'm building a base image that people are going to build on, I need the package manager in there so that they can install other packages that they need in their final image. But if this is my final image that I'm getting ready to deploy and run, I should never need the package manager in it. I shouldn't be dynamically installing new packages in what I have up and running. So that should be useless for what I'm deploying, but it's great for somebody who compromises that to potentially be able to do some recon in terms of what's already there, and to pull in additional packages to do other things. So this is a policy that looks for, is that package manager, whichever one, is it present in the image? And so, that's something that I would want if I was building out a full sort of security policy, a security program for things being deployed on top of Kubernetes and OpenShift. I would want to consider things like that. Let's reduce the attack surface. Let's reduce the usable but not useful to us code in those images. Let's strip them down to just what's needed. And the package manager is a great example of what might be in that image that I probably don't need once it's up and running. We have some other policies built in around things like curl and wget. They fit in the same sort of space. I shouldn't need curl or wget in a production application that's running in a Kubernetes world. So we can look for those sorts of things. We can look for things around how the images are actually composed. For example, if I can find it while I'm talking here, Docker says you shouldn't use the add command unless you absolutely require it in the Docker file and building an image. You should use the copy command. Add has a lot broader set of capabilities. You can read the rationale there in what's displayed right now, but it's best practice to use copy, not add. So we can look at that sort of thing. Are we building images in a way that meets best practice? And then we can also look at deploy time things. So not only how have I built the image, what's in it? Does it have critical vulnerabilities? Does it have the package manager? All of those things. Those are important. But also, especially in a Kubernetes world, it's important how we configure that thing when we deploy it. So we've got some YAMLs or a Helm chart or whatever that is that we're using to deploy it. We want to look at a number of things there as well. So as an example, running as privileged. This is one of those configurations that there are some pieces of Kubernetes and OpenShift and ACS that need to run as privileged because they do infrastructure types of things. But my application should never be running as privileged. If I'm, whatever my application, my workloads are, running as privileged, they shouldn't need that sort of privilege, I guess is the right word. So I want to catch those sorts of things at deploy time and say, hey, no, this shouldn't be running as privileged. This is problematic. There are lots of other ones, right? We want to specify resource requests and limits for exactly what it says there. If I don't do that, if somebody compromises my running container, even if they can't use it to do something useful like find data, move to other running containers, if I don't have resource limits specified, an attacker could potentially use my container that they compromised to run that node out of available memory or available CPU, effectively take it offline. So there are lots of things like that we want as well. So from an ACS perspective, we want to look at all of these things and the images we're building and the things we're deploying, which takes us back to pipelines. So what I've done in here, the way pipelines work is there are building blocks, or the way OpenShift Pipelines, Tekton specifically works. There are building blocks called tasks, and I've got some tasks. I've got some cluster tasks. The only difference is a cluster task is available in every namespace, every project, so it's much easier to consume those across lots of different things. And so I've got a task here that wraps up RoxCTL. RoxCTL is a command line tool that's part of ACS, part of StackRox. It lets us do a lot of things. One of the things it lets us do is take an image and scan it for all of those policies we're applying at build time. So all of our build time policies, the vulnerabilities, that does it have the package manager, all of those other things. And so if I look at this task definition, really what it's doing under the hood is it's grabbing a copy of RoxCTL to make sure it has the latest one. And then it's running RoxCTL image check to scan whatever image we're building. And so now I can take these tasks and I can use them as building blocks to put together my pipeline. And so I've got a pipeline here that really, I'm just pretending that I'm building something, but in a real pipeline, I would build my image. And then as part of that image, I would scan it and determine, did it pass or fail? And you can see I've run this a number of times in here. If I look at a sample and I look at my image check, what I'm getting back is actionable intelligence from the security tool, from ACS, telling me, first of all, my build failed. And it failed because we're enforcing the policy that we looked at earlier, fixable CVSS greater than or equal to 7, or do we have fixable vulnerabilities that are higher priority? And so I can see that I'm failing that, and I can see why I'm failing that, what I need to do to fix that, and I can see the vulnerabilities right here that I have to go fix in order to succeed. So I've got, for instance, a couple of libxSLT vulnerabilities in this image. I've got 1.1.31R1, I need 1.1.33-R2, etc. So I can go fix those things, and then obviously rebuild the image and succeed. But I can also look, there's some policies in here that aren't enforced, so they're not breaking my build, but still, while I'm fixing these vulnerabilities, I should, for example, add a user directive so that my runs as a specific user, not not as root, so not just expected to run as root, it's expected to run as a limited user and do one of those things. So this is a good example of taking those security concerns and embedding them into my pipeline alongside building this thing, checking it, seeing does it pass my security policy? Is it secure enough to run in our environment, or do I need to go fix things before I move forward? Now, that's with the image. We mentioned deployments and CI/CD. A lot of times we talk only about the CI half of that, right? But continuously building the things and then continuously deploying them. So as part of continuous deployment, we can use a tool like ACS or like Kubelinter or some other tool that's also going to look at the deployment and all of those deploy time things. Is it running as privileged? Does it take capabilities? Does it have resource requests and limits set? All of those things. We can look at the deployment as well and see, is this good? Is this worth deploying? Is this problematic or not? And so I've got another task, unsurprisingly, that wraps up RoxCTL deployment check. And I can see that, and I can run that against something. Now, in this case, it succeeded because I'm not enforcing any of those policies, but I can see that I have a number of problems in this particular deployment. One of the containers in this deployment is running as privileged. One of the containers is running as root. I don't have resource requests and limits specified. I have vulnerabilities. All of these problems show up here. So I can get that same sort of view. I can implement a pass-fail based on policy if I want to block the deployment before it ever actually goes to the cluster it's headed for, and get that. Now, one of the other cool things in Tekton that I think is an interesting problem-solving mechanism is this is all essentially on demand, right? I create a pipeline and I check in something and it triggers the pipeline to run or whatever else. But Tekton also lets me create independent triggers. And so I was spending some time with a different problem. And this is one that I commonly hear from security teams who are looking at sort of bigger picture issues, and not just a single pipeline, not just a single team building a single thing, but they're looking at if we have, for example, code coming from external, if we have things that are outside of our traditional CI process, how can we manage those and take action as well? And triggers are really cool for that. So what I've done here is I've got an event listener that listens, in this case, for a webhook coming in from Quay, from the public Quay registry. And so this is set up to create a listener. In my Quay repo, I've set it to send a webhook every time a new image gets pushed to Quay, to that particular repo. And then I've got bindings. I've got a template and a binding that essentially tie this together to run that same image check every time a new image gets pushed to my registry. And so you can see here, it takes the body, it gets the URL for it and the new tag, and it causes a task to run. And so I can see those same things happening here. If I search this, I can see very similar. I had an image pushed to Quay, and it scanned, and it returned a failure, and so I can do something with that and catch those things. This is really interesting for a lot of reasons. I talked to a few telecoms recently, and so a thing I don't think a lot of people know, but all of the 5G infrastructure to support 5G phones is being delivered on top of Kubernetes and OpenShift. So as a telecom, you're getting these things from your providers, your vendors, that are essentially artifacts. And then you're pushing those into Kubernetes, where then it's running the infrastructure that all of our phones run on, which is super cool. But one of the problems they have is if we're pulling this stuff in from vendors, how do we make sure that it meets our security policy? And this is one of the things we were talking about, is this sort of triggering based on ingesting those images and those packages, being able to pull them apart and do this sort of thing. So
that's a pretty powerful.
Yeah,
it's a pretty powerful mechanism there. Just to on that, dig down on that subject a little bit here. Essentially, because organizations are busy establishing this, and let's face it, not every organization has got things organized yet and has their full CI/CD pipeline built. But if we have the registry available, that's kind of that point of control. This allows me to get that visibility for the security team, even if, my development team is still catching up to the best practices. So it sounds like a great way to, get the security team the visibility they need without too much work on the part of the developers, and we can slowly, roll their work into the model here, right?
Yeah, absolutely. And I think also for that sort of supply chain thing, I think 5G is kind of on the cutting edge of some things, but we're going to see a lot more vendors shipping things as container images and Kubernetes deployments. And so being able to not only develop things in-house and get this, but also set up pipelines that take external sources like that and apply security policy, apply security scanning, return results, do various things with them, I think is really, really powerful and a great approach to getting into those things.
Yeah, it really changes the landscape of things because, at the beginning you cited some of those statistics about how much it costs to resolve an issue, right, in design versus development versus test and production. And to be honest, I've been doing this a long time. I've been hearing those stats for, 20 plus years. But here, because organizations are transforming the way they're building applications, we've finally got a place where that kind of activity is like, it's a natural fit for this. So even in cloud, even with virtualization and everything, is still a bit of an awkward introduction to get like a DevSecOps pipeline going in those kind of worlds. But here it seems like it just fits pretty easily.
Yeah, I would agree. It's I think these sorts of things go hand in hand. Microservices, cloud native approaches, Kubernetes, CI/CD pipelines, and then integrating DevSecOps into that bigger picture. All really goes together. And the fact that the way that the pipelines are architected so that I can really, so that we automate all of the sort of acceptance of testing and all of these things so that I can inject security policy into that and really, where necessary, enforce that anywhere along there is very, very powerful. It's a great combination of all of these things to apply security policy programmatically.
Now, for folks who may have joined a little bit late, we are taking questions live. So if you have something you'd like to ask about product, pipelines, strategy, industry practices, comments, something that you'd like asked there, we can answer those. We do have one that we get quite a bit about, those vulnerabilities that we see on the screen there. Do I have to fix all of them? Like, is that the only option? Generally developers are presented with a list like this and go, I'm not using some of these things. Why are they coming up as vulnerabilities? This isn't my code. Do I have to deal with this? Can I get an exception, right? Like, that's the first kind of reaction there, I guess.
Yeah, and I think that's fair, right? I mean, even a reasonable sort of image may have half a dozen vulnerabilities that are tripping over whatever the policy is. And I find there are a couple of approaches to this, right? First, yes, I think we all have to have some understanding that everything runs with some vulnerabilities, right? I've had a few security organizations who really tried to stick with, hey, we're going to run with no vulnerabilities, and that's not a reasonable world. The only way to run with no vulnerabilities is to have incomplete vulnerability scanning that's not showing you everything that's there. And quite frankly, I think is the only way you're going to get there. And in fact, I jokingly say that, but that's actually true with somebody that I worked with recently. Their existing scanning tool only scanned a portion of everything involved. So there were a ton of vulnerabilities that they didn't see because they weren't scanning the application layers of things. And so their security team was happy that there were no reported vulnerabilities, but there were actually a lot of vulnerabilities inside of what was there. So, I think certainly that's an open question of making sure that you're getting all the vulnerabilities. But step one is absolutely figuring out what's really critical. But step two is looking at, not just fixing vulnerabilities, but maybe working around them. And this is what I've got on screen here is a great example. So APK tools, I'll be the first to admit I have not spent as much time with Alpine as I have with other platforms, and I think that this particular image is Alpine based. But I'm pretty sure APK tools are tools for manipulating and installing packages in Alpine. I may be wrong, and if I am, let's just pretend I'm right. If that's what this is, then why do I have it in an image? Once again, like having the package manager in there, there's no reason I should need a component that manages Alpine packages. So let's just strip that out. Let's just, instead of fixing the vulnerability, let's remove the component entirely so that it's not in that image. I've reduced the surface of what's there. I've reduced the size of it. I've de facto fixed any vulnerabilities that package might have in it. And I've iterated towards a much more minimal image that has only what I needed.
Yeah, that seems like a great idea. I mean, if I find that I've got all these components that I didn't even know that I had, and this message is making it clear to me that it's my responsibility to maintain those, I don't want to. So, like, if I'm not using it, like BusyBox might be really useful, but if it's not something that my application depends on, I'm just going to get rid of it. I suppose the corollary to that too would be, when I've got a vulnerability in a library, like let's say I am using libxslt and I've got it, dynamically linked in my application, I've got a dependency on that. It's something where I don't want to see that modified for me, right? Like as the developer, I want to get this information because maybe I don't want to go to 1133R3, I want to go to 1134, right? Like I want to have some flexibility because something naively applying a fix to a known fixed version has the potential to just break the whole thing, right? So, I mean, it seems like this is a great way for a developer to get, kind of that pre-flight check and understand what's going to trip them up, but make an intelligent decision about which direction to go with all of this, right? I don't necessarily have to go to that version. I don't necessarily have to have that library in there if I can just go out and make a change that would, as long as I get to a resolved version, then security's happy with that, right?
Yeah, absolutely. And I think you're right about automated patching, right? From the security side, we kind of grew used to that, right? We grew used to Windows Update and all of the other automated patching solutions for desktops and servers. Even then, I spent some time behind some of those things. At Microsoft, there are jokes about Patch Tuesday because the Wednesday after Patch Tuesday, there's always a flood of support calls for things that people think updates broke, and sometimes they did. It's much more critical when you start looking at libraries, like you said, that are linked to other libraries, that you get that right and you have somebody who understands it and you don't just automatically update versions and see what happens. So, yeah, I think this is a good tie back into the bigger picture of DevOps, where we have DevOps teams who understand their applications and are building them and putting them together, and then the automation is helping to test and deploy them along from there.
We got another question from the audience here. How long does it take to spot a vulnerability and mitigate this? So, like, there's a couple of timing questions there, I think, but how long until I see this kind of data about my dependencies?
Yeah, so annoyingly, one of the things Pipeline doesn't do that I can find is show me how long each stage took to run. But typically, I hadn't realized that wasn't there. I'm so used to seeing it in Jenkins, for example. Typically, the image scanning takes like 15 to 30 seconds. I know it takes less than 28 seconds in almost every instance because of some other work we've done. So it's a matter of pulling the image and then decomposing the image into the components and then matching that up with known vulnerability data. Presuming that the image pull doesn't take very long, it's going to be very, very quick. It's going to be 10 to 15 seconds to add this into a pipeline.
Right. And when a new vulnerability is discovered, that data is already in ACS because we're pulling it from the various sources out there. And so every run that I have here could potentially be different, right? Something could be newly discovered in the interval between this morning's run and this afternoon's, and I've got something else that I have to deal with, namely a newly discovered vulnerability, right?
Yep. And then I think the second half of that question How long does it take to mitigate? That's a much more difficult question, right? Because that gets back to we need somebody to do the work. We can see that the pipeline failed, or in a sort of larger ACS environment, we might create a JIRA task or do something like that. So then there becomes a question of that human element of how do we prioritize that? Somebody picks it up, does the work, potentially finds there are other libraries linked to that library that they have to update. So I think that there's certainly a finite period of time that's much longer than 15 seconds that it takes to fix it after it's found. But adding this into a pipeline for almost any of the tools I've looked at is reasonably quick, right? About 15 seconds for ACS, very similar for Claire or Kubelinter or any of the other sorts of tools that you may see used to do security policy checking and security scanning in the CI pipeline.
Well, if I'm a developer and I know what I'm doing, I'm going to quickly try to automate the package updates for the things that I do depend on, right? Because keeping those updated with every single build kind of gets ahead of the problem, right? Instead of getting this report, going back, researching the versions of this stuff, I just want to say, hey, use APK and Alpine to update the package sources and get the latest version in there, right? I want to have a way that I'm going to get the vast majority of that just by running the build again, rather than having to deal with them piece by piece. And I suppose the other side, a good developer is an impatient developer. I might spend a little bit of time up front to try to reduce the surface area that's on that Alpine image or whatever, so that I'm not bringing in so much in the first place. Because if it's not there, then I don't have to maintain it.
Yeah, absolutely. And I think, Alpine, Red Hat UBI are great places to start for that sort of minimalism. And, even possibly moving towards Scratch containers for things that are very, very single purpose. But I think, taking a platform that is minimal to begin with and then adding only what you need. And then figuring out, can I have a reasonable update cycle to just, update all of the libraries I'm using. And then, I think you've got to have some knowledge of where you have to pin libraries to a particular version if there's risk of updates breaking something. But that's all developer stuff, right? Somebody's got to figure that out and have the expertise to do it, or they're going to be chasing failures later on.
Yep. Now, Neil, you mentioned Scratch images, and I'll point out to the audience that we've actually done another office hours on building and using base images in a better way. I did that with another colleague of mine, and we talked a little bit about how to get these images, how to build them, what a minimal image looks like, and how to parse through them with tools that allow you to walk through the image contents. I mean, it's all about providing visibility into how much you're actually bringing in when you get an image, and how much less you have with something like one of these minimal images like Red Hat UBI or like a Scratch image, which is really just nothing, nothing on the file system other than your application components. But take a moment here to switch gears a little bit. You mentioned Kubelinter, and I'm interested in seeing what you want to have there. Unless we have anything more on this time, I thought we'd get to that before we run out of time today.
Yeah, so unfortunately, today was the day I had some time to work on that. So I haven't actually gotten my pipeline working yet. So you catch me a little bit off guard, but it's a good chance to look at Kubelinter. Sorry, I'd known Chris was going to ask that. I would have already had it open. But if you're not familiar with it, Kubelinter is a tool for analyzing YAML files and Helm charts that you're going to deploy Kubernetes stuff with and looking for typical security misconfiguration. So it's a great tool. I think I was hoping that there was an example here of output from it. It's just not going to be my day for that. But this is a great tool for doing some of the stuff like the RockCTL deployment check does, but doing it without a back end of some sort, right? Just saying, here are the tests we're going to run. We're going to look at, is this running privileged? Is it setting resource requests and limits? All of those sorts of things. And so really what I'm doing, and actually, Chris, I'm glad you asked this because there's another thing that I'm going to, oh yeah, there is some output here. that I did want to show before we run out of time. So this is a typical, here's a deployment YAML. You run kubelinterlint, and it returns some errors here indicating that it does not have a read-only root file system. It doesn't have a CPU limit check. It doesn't have a memory limit check. And so this is the sort of thing, and once again, this is a great check prior to actually deploying something to look at it and say, does it meet these does it cover these security issues, or is it broken in some way? So, yeah, this is what I'd like to do. Now, while I'm talking about GitHub, though, the other thing that you should know if you want to see what some of this stuff looks like, all of this is in the GitHub StackRox contributions repo. There's a CI area here that shows typical StackRox ACS CI integrations. And everything I've done today is in the Tekton, in the Tekton piece. Actually, I take it back. The trigger is not here yet. I'm going to be writing up the trigger and adding it here. And when I get the kubelinter task running, we'll add that here as well. So if you're looking for some tasks specifically for Tekton or OpenShift pipelines, you want to get an idea of how this would look, they're all here. They're all available. All of the ones that I've finished so far are available. So.
Yeah, so this is just a question about these links to these repos and things like that. We'll make that all available. It should be part of the resources that are part of this. This event's also being recorded, so we'll get you all of that information out there. But this is on the public organization called StackRox on GitHub. You'll see a few things in there. This is going to be part of the StackRox community. So contributions like this we're taking from our customers, from users out there, and all of the code that you saw in the pipeline there is available today in the repository that Neil built. As Neil's off on of saying, there's probably not a CI or a CD tool that we've seen that doesn't work with, that we can't make to work with this model, because the CI tools all take this task-based approach. They use different terminology. It's pretty broadly compatible with these kind of checks. We think it's an ideal place to insert the security checks that the organization needs to really to make the DevOps story a DevSecOps story.
Yeah, and I was going to mention just very briefly, it's not published yet, but Mark Roberts, who's a peer of ours based in the UK, is writing a blog with a deeper example of what this might look like in a CI pipeline and some pieces around that. So keep an eye out. I know he's working towards publishing that as well. But he's got a really good write-up on walking through sort of a sample implementation in more detail and what you'd be accomplishing and how you'd be accomplishing that.
Great, well, folks, we're taking questions. If you have any questions about pipelines, about image scanning, about security, and on OpenShift in general, we're happy to take those questions here in the Q&A section for the interface. Neil, in the meantime, you mentioned something else you wanted to show.
Oh, that was the contributions repo. I wanted to make sure to plug that as well. If people were looking for, like Ritam, we're looking for, what does this stuff look like? How do I get this? What do I do with it? There's good examples out here of what that would look like. And so, yeah, if you want to play around with this, I've got some samples out here of essentially what I was doing and a write-up and the tasks that I have in there. So, yeah, have at it, play with them, and definitely, if you want to use a different tool, if you want to use Claire or something else, this same model would probably work well for building your own integration for whatever it was you wanted to test with and whatever it was you wanted to scan with.
Yeah, I've been meaning to ask you about this because you and I have both worked on some of these and have had various tools that we've worked with, and we've noted the problem that you've got to get the RockCTL tool here in the first place, right? And authentication and all that. Now, and keeping with the open nature of Red Hat, that ROCCTL binary is now available through Red Hat sources. Does that make our lives easier here? Is that a good thing to do, you think? I know, like, keeping track of the versions is a pain. I don't know, does that give us a little bit more flexibility?
Yeah, so what Chris is referring to here, in my sample, you'll see that what I do is reach out to Central, which is the management piece of your ACS deployment, and grab the latest copy of ROCCTL, make it executable, and then use it. And I think there are a couple of approaches here, and this is sort of going to depend on the tool and what you want to accomplish. I do it this way just to make sure that it stays in sync with whatever version of StackRox or ACS I'm using. So I don't end up with, 3.0 of ROCCTL 3.0.49 when I'm using release 3.0.60 on my deployment. That's useful because there are certainly some changes over time in ROCCTL. There have been some things that have been added and changed. And so it just reduces the chance of a change being introduced which breaks something, and then I end up spending time troubleshooting that, trying to figure out what happened. I think it's certainly acceptable if you want to if you want to download the binary and manage it in if you want to use an image that has that binary embedded in it, if you want to do something else like that. I think there are a lot of approaches. For ROCCTL, for example, there is an image out there that has ROCCTL embedded in it. You can use that instead if that's what you wanted to do, and you don't have to download it to run it. I think, this is just what problem are you trying to solve and what's most important to you.
Yeah, certainly downloading it from the control plane works better for me if I'm running everything on-prem or just in a private cloud environment where, hopefully my dev systems don't actually have that internet access, right? Where, there's security restrictions at the perimeter that would prevent me from getting out, because that's, off topic for this conversation, but a good practice a lot of enterprises follow. And I hope our 5G telecom folks are following that. But this is going to be running entirely as software in their environment, which means the control plane is a convenient place to get that rather than from some site on the internet, even if it is Red Hat.
Yeah, and lots of ways to approach that. What's up here is really intended as samples, so I try to make them as broadly applicable and as whatever the opposite of prone to failure, stable, I guess, as I can make them. And so for me, this is the easiest approach. I think if you see this as a problem because it introduces an extra half second in every run, and that's unacceptable, then you can take a different approach and figure out how to manage that. But it's really what you prefer, how you approach that in the pipeline.
Now, I saw somewhere else you also had the image scan, which is like the machine-readable output for images, right? That meets a lot of different requirements that maybe I'm not being able to meet today with like the human-readable output. Like I want something in a CSV spreadsheet or something, right? Yeah,
and so what Chris is referring to, let me grab a pipeline here. So you actually see I do an image scan and an image check. Image check returns that policy-based. This passes all the policies, it fails this one, and this one. Image scan returns all of the vulnerability data in a couple of different formats, or possibly in different formats. So it gives me every vulnerability, the component it's in, what layer it's in my image, all of that information. So here, like I've got this output in CSV, so I could capture this as a file, make it available as an artifact. So if my developers look at this information and go, well, I don't know where Node.js came from, they can go to this data and look at every component and vulnerability in here and see, all right, that was introduced in, this is actually this is a scratch image, so there's not much in the layers, but if it was a better image, I could see which layers each of these things was introduced in. And we can do that in ACS. We can do that in JSON format if I want to parse it myself, if I want to use that in some sort of machine-readable way. We can do it in CSV output, and we can do it in pretty output where it's much more human-readable if I want to just consume it in line here. But yeah, that gives me the ability to not just get sort of, here's what failed, but to get every vulnerability with its CVSS score and whether it's fixable and all of that information.
Interesting. So it's a complete record of everything, all the layers, all the components. It's everything, not just the ones that would fail my policies.
Yeah.
Cool. That's quite an eye chart there. But it is certainly something that
obviously my CSV output I would want to save off and open up somewhere else. You know, if I look at it and say pretty format, it has some control characters in here. I haven't figured out how to strip those out, but you can see here it's mostly more readable. So I can see, for example, here's a layer in my Docker file, and here are all the components and vulnerabilities in those components and those layers. So, for example, this was the one where we saw the libxSLT vulnerabilities. There are those vulnerabilities, and I can go look and say, all right, that's in this layer where I run apt-get, I think. It's a really long layer, but yeah. So I'm pulling all these things in, so I can go back and say, all right, here's where I would have to go to fix those particular vulnerabilities.
Huh. Interesting. So the layers are separated out. That's a cool thing because, potentially I'm not the one who built, I didn't build the base image. I may not have built, what gets handed to me to use here, I may have built on top of somebody else's work. So I can easily tell if this was something that my own code introduced or if it came, from another team that's responsible for building images. So that's pretty cool. We've learned something new.
Yeah. So
back to the audience, folks, if you have any more questions, if there's anything that's unclear here that you want us to review again, we're happy to take those. This is going to be recorded, so you'll be able to review this later or send it to others. It'll be out on the StackRox community channel for YouTube. We have links to all of the resources out here that you've seen. All the stuff that we talked about has been public. But if there aren't any other questions last minute here, Neil, any closing thoughts?
I appreciate everybody coming and joining and sitting with us for a while to chat through this.
Great. Well, thank you, everyone. It was certainly wonderful to have so many people on listening. Hopefully it was valuable for you. If you like this, we're going to have a continued series of these. Keep an eye out for both Neil and I as part of Red Hat events as well. Generally, if you see Red Hat and OpenShift and security, you'll probably see one of our names attached to those events out there. We're looking forward to it. We're looking forward to getting back to meeting folks in person someday. Thank you again, Neil. Thank you. It's always a pleasure. Have a great day, everyone. Take care.